Chicago loses an astounding 96 million gallons of water every single day, enough to fill 145 Olympic pools. This quiet crisis is quietly draining urban grids across the globe, with over 1,000 hidden leaks going undetected, essentially pouring money and resources straight into the ground. Consider this: Chicago's 4,300 miles of pipes stretch further than the distance to Los Angeles, and this aging infrastructure is steadily failing. It's more than just wasted water, it's a fundamental structural threat with an astronomical unseen cost. Nationwide, more than 1.8 trillion gallons disappear each year, a deficit exceeding all residential water use combined. Repairing these unseen ruptures runs into the billions, and often, pinpointing the exact source is a maddening mystery. A leak as tiny as 1/8 of an inch across can waste 3,000 gallons daily. That's a bathtub every 30 minutes. These leaks are destabilizing the very ground beneath our feet, leading to sinkholes and road collapses that endanger citizens. For an average family, 10,000 gallons vanish annually from household leaks alone, and you can only imagine what that looks like scaled up across an entire metropolis. Cities are losing 20 to 30% of their treated drinking water, and some areas suffer even greater losses. Imagine 4,300 miles of pipes snaking beneath your city. That network is immense and unforgiving. Chicago's daily loss of up to 96 million gallons from these failures means 145 Olympic pools are just emptying into the earth. Some of these pipes are over a century old, a time when leak detection technology was barely a concept. Imagine surveying 200 miles of pipe in a single night, when before, cities were lucky to scan 2 to 3 miles per day. This was the losing battle against aging infrastructure. With many pipes over a century old, 2 out of 3 major lines far exceeding their intended 50-year lifespan. Decades of patchwork fixes had tangled a decaying labyrinth underground, constantly fighting pressure and corrosion. The cost? Cities were losing over $80 billion annually to water main breaks alone. Then, one engineer offered a radical idea: Project Argus. It was a controversial plan to use high-altitude thermal aerial scans, a vision to mount ultra-sensitive thermal cameras onto aircraft, scanning entire cities for subtle temperature anomalies. And first, engineers scoffed, calling it science fiction. They believed the city's own heat would render any faint leak signature invisible. But the key was new uncooled microbolometer sensors, capable of detecting temperature shifts smaller than 0.05 degrees Celsius. Early trials showed the system pinpointed simulated leaks with 95% accuracy, even through concrete. This audacious project, born from desperation and technological leaps, finally won funding from the City Council. Atlanta's aging pipes were bleeding thousands of gallons daily, and one city's Project Argus found over 1,000 hidden leaks, enough to fill a small lake each day. They weren't using just any camera. This was an instrument so sensitive it could detect the faint warmth of escaping water through layers of asphalt. Each specialized aerial camera packed a 1280 by 1024 resolution, far sharper than typical thermal sensors, capturing high-definition images from 3,000 feet up. Twin-engine planes buzzed over the city at about 150 miles per hour, flying precise, overlapping grids to cover every inch of infrastructure. Night was the secret ingredient, the best scanning time between 1 a.m. and 4 a.m., when solar heating vanished and temperatures leveled out. Inside, computers crunched terabytes of data each night, filtering out noise and flagging potential leaks the size of a dinner plate. One scan covered 100 square miles, a monumental hunt for tiny warm spots. It was like finding a single warm pebble on a vast, cold beach, but with real consequences. These flights weren't easy. They fought fog banks rolling in from the coast and dodged air traffic over dense neighborhoods. Imagine flying precariously close to skyscrapers, constantly aware of air lanes. While Atlantans slept, this team worked tirelessly, safeguarding the city's water supply and saving an estimated 20,000 gallons every minute. Each mission shot hundreds of thermal images, generating a staggering 500 gigabytes of data nightly. The sheer volume was immense. To ensure they didn't miss a thing, the aircraft flew overlapping paths, covering about 200 square miles nightly. That's 9 times the land area of Manhattan Island. They'd even cover up to 400 square miles per night. When the final data from the aerial scan landed, it wasn't just a report. It painted a stunning, never-before-seen portrait of their city's hidden crisis. This thermal fingerprint revealed 1,127 leaks beneath roads, sidewalks, and parks, precisely where older methods just couldn't find them. Each red dot on the map was a confirmed leak, a warm signature of escaping water pushing up through soil and pavement. The estimated annual savings were monumental: 10.5 billion gallons, enough to fill 5,300 Olympic-sized swimming pools. The scan pinpointed that 65% of these leaks originated from the smaller service lines connecting to homes, with the remaining 35% stemming from larger distribution mains. The fastest repair crew got to a leak within 48 hours of detection, preventing countless gallons from further seepage. Municipalities are now saving millions each year by shifting from reactive fixes to proactive, targeted interventions. The sheer scale of previously unseen water loss was honestly shocking. A true hydrological crisis lay bare. On average, each newly discovered leak was losing 2,000 gallons every single day, adding up to a colossal collective drain. This aerial view fundamentally changed urban water management worldwide. Financial projections showed cities could recoup the scan's cost within just 3 years. Over 20 different soil and pavement types were accurately penetrated, revealing leaks regardless of the surface material. From asphalt to parkland, the scans exposed the urban landscape's hidden veins. Each previously undetected leak can hemorrhage 1,500 gallons daily. That's 18,000 bathtubs of water lost annually. Creepy. This technology offers a perspective previously impossible from the ground, a true God's eye view of our municipal infrastructure. Imagine this: 1 trillion gallons of treated water saved globally each year. That's enough to fill over 1 million Olympic pools. Today's systems can tell freshwater from sewage and industrial runoff, a huge win for the planet. Some advanced thermal sensors are incredibly precise, spotting temperature changes as small as 1,000th of a degree Celsius. That's about 100 times more sensitive than your home thermostat. And we're seeing these systems pop up everywhere. The number of cities using them has doubled in just 5 years, from 50 to over 100, all safeguarding precious resources. It's like we gave our cities thermal eyes, boosting detection rates by more than 300%. This is essentially a new sensory organ for urban life. But it's not just leaks. Thermal imaging reveals urban heat islands, guiding planners on where to add trees or improve buildings to cool neighborhoods by up to 5 degrees Celsius. A quick aerial scan of a huge city now takes less than a week, mapping over 3,000 kilometers of infrastructure. That generates massive amounts of data, petabytes of thermal images crunched by AI. It's a blueprint for the smart cities of the future, offering a live look at how our urban centers function. What started as a mission to find leaky pipes has grown into a powerful way to understand and strengthen our cities.